Hello friends, welcome to Cortex YouTube channel. In this video, I will teach you about the beta blocker overdose and its clinical features and its management. So before going to the features and management part of this topic, let's discuss about basics of the beta receptors and beta blockers. So these beta blockers are used in so many various conditions like endocrinological conditions, neurological, psychiatric, cardiovascular conditions. So these beta receptors are mainly of three subtypes: beta 1, 2 and 3. So where these are located and what are these actions? So let's look at them. Beta 1 receptors are located on heart. So many of you know it is located on the heart, and a very good doctor will know it is located on the kidney and eyes also. So heart, the stimulation of beta 1 receptor present on the heart will cause increase in heart rate and increase in force of contraction, that is positive ionotropy and positive chronotropic actions. So the stimulation of beta receptors that are present in the kidney, okay, will cause release of renin, okay, and it will cause increase in aqueous production. So beta 2 receptors, they are present in various smooth muscles and skeletal muscles like vascular smooth muscle, which causes vasodilation, and visceral smooth muscles, which relaxes the viscera, that is your uterus, and bronchial smooth muscle, it causes bronchodilation. And beta 2 receptors present on the liver on stimulation will cause glycogenolysis, that is breakdown of your glycogen to form glucose, okay. Then skeletal muscle, again it will cause glycogenolysis, which is glycogen is also stored in the skeletal muscles, okay. Then beta 3 receptor stimulation, which is present in the adipose tissue, will cause lipolysis, and that again, see, glycogenolysis, lipolysis, they are all suggestive. They are all forming glucose, which is very necessary when there is sympathetic overstimulation, okay. And beta 3 receptors are also present on the skeletal muscle, which causes thermogenesis on stimulation. So these are the receptor subtypes and their location and the possible actions. So if you block these receptors, what happens? So your heart rate will go down, force of contraction will go down, so you will get bradycardia and hypotension, okay. And the bronchial smooth muscle beta receptors, when blocked, will cause bronchospasm, so patients will be breathless, okay. So if the beta 2 receptor is present on the liver and skeletal muscles are blocked, so they won't form the glucose by glycogenolysis, so hypoglycemia may tend to happen, though it is uncommon, but it can be expected in beta blocker toxicity, okay. So this is about the basics of the beta receptors and the actions, okay. So how they act on the molecular level, let's discuss. So what are these beta receptors? Beta receptors are nothing but they are membrane bound glycoprotein. So this is, let's suppose this is a cell membrane, okay. Cell membranes have so many receptors and channels. These cell membranes have calcium channels, okay. What are these calcium channels? These are L type of voltage gated calcium channels. They will allow this calcium whenever they are stimulated. So this calcium can enter, okay. Who stimulates this calcium channels, or who increases the activity of these calcium channels? That is your beta 1 stimulation. So let's suppose this is your beta 1 receptors. So this is the glycoprotein receptor that is situated in the cell membranes, and this is, let's suppose this is your beta 1 receptor, and it is a G protein coupled receptor. What I mean by that, it is linked to one extra protein, that is G stimulatory protein. This is GS. Whenever a beta agonist binds to beta 1 receptors, it stimulates the beta 1 receptors, which in turn stimulates the G protein subunit, that is GS subunit, and upon stimulation of GS, it will act on the adenylate cyclase which is present in the cell membrane. This is adenylate cyclase. So what does adenylate cyclase does? Adenylate cyclase, that is AC, will convert the ATP into cyclic AMP. Okay, the cyclic AMP is very important because it acts as a secondary messenger. Okay, so cyclic AMP will then activate this protein kinase A. Okay, this protein kinase A gets activated by this cyclic AMP, and this protein kinase A will go and phosphorylates these calcium channels and activates them and allows the entry of calcium, more calciums. Okay, so what does calcium do now? Entered calcium will go and bind to the sarcoplasmic reticulum. So let's suppose this is your sarcoplasmic reticulum. Okay, sarcoplasmic reticulum has a special calcium channels. What are these channels? These are called as Raynaudin channels, RYR. Raynaudin channels. So this calcium goes and binds to the Raynaudin channels or stimulates this RYR channels and allows the sarcoplasmic reticulum is rich in calcium. It is a storehouse of calcium. So much calcium is stored in the sarcoplasmic reticulum. So calcium from the sarcoplasmic reticulum, that is SR, will now enter the cytoplasm. So this is called as calcium dependent calcium influx. So this is also RYR, that is your Raynaudin receptor. Calcium comes into the cytoplasm, and what does this intracytoplasmic calcium does? This will go and act on the myosin and actin complex, thereby increasing the contraction. This will act on the myosin, and there is an interaction between myosin and actin, and thereby causing the contraction and increasing the force of contraction. So this is what is happening in your myocardium, skeletal muscles. Okay, so this process is enhanced. The calcium entry is enhanced by beta 1 stimulation. Okay, those drugs which act on the beta 1 receptors, those drugs which stimulates beta 1 receptors will stimulate the calcium entry and thereby increasing the force of contraction. I hope you are understanding this. And one more trick here is glucagon, that is secreted by alpha 1 receptors of the pancreas. Glucagon will directly act on the adenylate cyclase. It doesn't require any GS or beta 1 receptors to stimulate this adenylate cyclate. It independently acts on the adenylate cyclate, and thereby all the downstream actions will be happening. Your conversion of ATP into cyclic AMP, and thereby pKa, phosphorylation channels, and entry of calcium into the cytoplasm and contraction of the this muscles. So this glucagon is important. Okay, remember that we will when it comes to the treatment part, I will explain in detail about the glucagon. Okay, now this cyclic AMP that is produced by the action of adenylate cyclase will be converted to an inactive compound, that is 5-AMP by the action of phosphodiesterase enzyme. Again, this is an important part here. You have to remember, and while discussing treatment, I will tell the importance. Okay, there is also calcium here. Extracellular calcium will also be there. So if I increase the extracellular calcium, more calcium will enter the cells. Okay, that also you have to remember. That also helps in the treatment management of this condition. So this is the basic that you have to remember before proceeding to the features and management of the beta blocker toxicity. So let's proceed to the beta blocker toxicity.